Hello everybody, so welcome to part 5 of toxin sequestration theory. This is my new theory of cancer. It's very different from the mainstream view, and it's also different from Thomas Seyfried's view as well. So what does my cancer theory say? It argues that number one, cancer is not a disease, rather it is a symptom of toxic overload, and the true disease is toxic overload. Number two, cancer tumors are not selfish, malignant, uncontrolled growth. Rather, they are the body's defense mechanism against toxic overload. And a cancer tumor actually represents extra tissue that the body creates on purpose for the purpose of storing, processing, and sequestering toxins. And that's the basic idea of the theory. I've now sort of mapped it out for various different toxins. We've talked about seed oils, oxalates, heavy metals, deuterium. We've talked about glucose and fructose. We've talked about ethanol and cigarette smoke. We talked about microplastics and mycotoxins. So there's this whole wide range of toxins that we've discussed, and all these toxins basically show the same picture. They're all preferentially sequestered by cancer cells, where cancer cells pull these toxins in out of the body fluids, and then once inside, the cancer cells will either store them or process them, and that depends on the nature of the toxin. If the toxin can't be processed, things like heavy metals or oxalates or microplastics, then it just stores them. So it literally just stores those toxins for safekeeping. But when the toxin can be processed, things like ethanol or cigarette smoke or the sugars like glucose and fructose, then what the tumor does is it dramatically upregulates its detoxification enzymes to process and detoxify those toxins. Okay, so that's the basic picture. Like I said, this is called toxin sequestration theory, or TST for short. And in this video, I'm going to talk about extending this theory in a tissue-specific way and trying to answer the question of why do tumors form in specific organs? Why is it that certain cancers are so much more common than others? Things like prostate cancer, breast cancer, lung cancer. Why are these cancers very common, and why is it that, for example, heart cancer is rarely ever found? In fact, mainstream medicine doesn't really have a good answer to this question, because from the mainstream view, cancer is caused by genetic mutations, and these are random. So you would expect if genetic mutations were responsible for cancer, then you would just randomly get cancer in all different organs, including your heart. You would expect heart cancer to show up, and yet it never does. In practice, by the way, it's very, very rare for a cardiologist to ever see a single case of heart cancer in their entire career. So it's not uniform. There are certain cancers that show up more than others in practice. Basically, what I have formulated is what I call tissue-specific toxin sequestration theory. The acronym is TSTST. And in that theory, it helps to explain why certain organs have cancer more often than others. It has a couple key principles. Number one, it says that the body does not sequester toxins uniformly. It strategically chooses specific tissues to use as sequestration sites. Number two, it says that tumors often form in tissues that are most heavily burdened by the toxic load, and this, of course, makes sense. Imagine that there's certain tissues that are detox organs, like your liver, and that's going to be most heavily burdened by the toxic load. And there's other situations as well where organs are highly exposed to toxins, like skin, for example, would be exposed to toxins a lot. And that's why skin cancer is very prominent. But the number 3 principle is that tumors also often form in tissues that are best equipped to safely sequester and isolate the toxic load. So there's going to be some tissues that are just really good at sequestering toxins, and a great example of that is the prostate, and we'll get into that some more. The reason why prostate cancer shows up so much is that it happens to be a tissue that's really good at safely sequestering and storing toxins. And mainstream medicine cannot explain that, right? That's really only something you can explain in this theory. And then finally, the fourth principle is that critical organs, like the heart and the spleen, are almost never chosen, as tumors there would immediately threaten survival. So the body is very careful about trying not to build a tumor in a place where it would threaten the survival of the organism. So those are the basic principles of tissue-specific toxin sequestration theory. And so let's go through them one by one. So let's talk about the fact that tumors tend to form in heavily burdened tissues that are burdened a lot by toxic overload. And the first organ that comes to mind there is the liver. It's our primary detox organ. So naturally, liver cancer is very common. It's one of the most common cancers. So for example, chronic alcohol consumption gives rise to liver cancer, and also iron overload gives rise to liver cancer. So anyway, that's another. So there's another one is the lungs. So the lungs are the primary exposure to inhaled toxins, and there's a variety of inhaled toxins. Of course, the one that first comes to mind is cigarette smoke, but it's not just cigarette smoke, it's also microplastics. Microplastics are airborne. For example, car tires, when you drive a car, they release microplastics into the air, and then people breathe in the microplastics from the car tires. There's also a lot of volatile organic compounds, things like formaldehyde, that you can breathe in. And so lung cancer is very common. I believe it's like the third most common cancer, and this can explain it. Basically, it's a heavily burdened tissue. Kidneys as well. Kidneys are also heavily burdened. They're a detox organ, so they're exposed to oxalates and heavy metals. Kidney cancer would be a result of the fact that the kidneys are just really highly exposed to toxins. Now let's look at the next principle, which is that tumors form in tissues that are best equipped to safely store and sequester toxins. And the three tissues that come to mind here are prostate, breast, and colon. Those are three very common cancers. Prostate cancer, breast cancer, and colon cancer are very common. Why is it that those cancers happen to occur so much? It's not that those tissues are super highly exposed all the time to toxins. Rather, it's that they're really good at sequestering and storing toxins. And in the case of the colon, it has a really large surface area, and that allows it to safely wall off a lot of toxins that it's exposed to. So it can be exposed to mycotoxins from the food, and basically these are mold toxins that people eat, and the colon's really good at kind of walling off those toxins and isolating them from the rest of the body. So the body asks the colon to do that job and create tumors, whenever there's a lot of toxic overload. Once again, with the breast tissue, it also has good capabilities for handling estrogen. So many people have estrogen overload, too much estrogen in their body, and the breast tissue is excellent at basically sequestering and processing estrogen. So high estrogen is linked to breast cancer, but that's not because necessarily, it's basically because the breast tissue is really good at sequestering and processing estrogen. So it's kind of like a detox organ for estrogen. And in the case of the prostate, it has really high levels of fatty acid transporters, and we're exposed to seed oils. Seed oils are toxic fatty acids that create oxidative stress in the body. And the body says, where the heck can I store these seed oils? And the body says, oh, look, there's a nice little organ down there called the prostate. It's not an essential, like super essential organ for survival. So if you get damage to your prostate, it's not necessarily going to immediately threaten your survival, unlike the heart, of course. And so the body just says, let me use the prostate to store seed oils because it has all these fatty acid transporters on its surface. And so it's already well equipped to pull in seed oils and store them. And so, yeah, so that explains why prostate cancer, breast cancer, and colon cancer are very common. They're really well equipped to handle toxins. Um, and and I want to contrast that with the heart, where it would be life-threatening if you had a heart tumor, right? Your heart wouldn't be able to function properly as the body's pump of blood, and so even a small tumor could impair the cardiac output and threaten your survival. So the body's not going to do that. It's not going to put a tumor on your heart. And then similarly with the spleen, that's also rarely chosen, and that's because the spleen's job is to basically fight infections. And so if you had a spleen tumor, it could impair the body's ability to fight infections, and that would pose an immediate threat to your survival. So yeah, that can explain why heart cancer and spleen cancer are much more rare than other types of cancer. So just to sort of summarize, we can go to like the most common cancers, which are things like prostate, breast, liver, pancreas, colon, and lung, and we can also identify the key toxins that are associated with those cancers. So in the case of the prostate, it's seed oils, like I said, as well as excess iron and oxalates. In the case of breast cancer, like I said, it's excess estrogen, as well as oxalates and seed oils. Oxalates have been shown to highly concentrate in breast cancer tumors. In the liver, it's a different set of toxins. It's actually excess iron, ethanol, fructose, and mycotoxins, the mold toxins. And that makes sense because we all know that the liver's job is to process ethanol, so it makes sense that that's connected to liver cancer. Same with fructose. Fructose is processed in the liver, so it makes sense that excess fructose is connected to liver cancer. In the pancreas, the two most common toxins there are the sugars, fructose and glucose, and of course, pancreas deals with a lot of sugar-related issues. In the colon, it's seed oils and mold toxins, mycotoxins. In the lung, it's all the inhaled toxins. So it's the smoke toxins, cigarette smoke, car exhaust fumes, aldehydes like formaldehyde, as well as microplastics, like I said. So what's exciting about this is that it allows us to create a toxin-to-organ mapping. It allows us to basically figure out if you are exposed to a given toxin, what type of tumor would you expect to get? And like I said, we can just map this out for specific toxins. In the case of seed oils are mapped to largely the prostate, the colon, and the breast. And so if you have seed oil overload, that's the type of tumor you would expect to get. And for iron, it's predominantly the liver, but also to some degree the prostate. And for excess estrogen, it's predominantly the breast. So you would expect to get breast cancer if you have excess estrogen. For fructose and glucose, it's number one, the pancreas, and then also the liver as well. And for oxalates, it's prostate and breast. And we can keep going down the list, but the point is that we have now a very exciting mapping from specific toxins to specific cancers. And so if someone comes to us with a particular type of cancer, we can give them potentially advice and say, well, if you have, say, breast cancer, then, chances are you have excess estrogen and you should try to reduce estrogen in your life. If you have prostate cancer, you likely have seed oil overload and you should try to reduce intake of seed oils, right? And we can keep going down the list. For liver cancer, it's going to be that you have excess iron or excess alcohol consumption, ethanol, right? And so I think this is very exciting, this toxin to organ mapping, because it allows us to actually give people advice of what toxins they need to prioritize cutting out of their daily lives. Um, and finally, I want to just reiterate the fact that this gives us a better explanation of why cancer tumors form in specific organs relative to the mainstream theory. The mainstream theory really struggles to explain why is it that prostate cancer is so common and heart cancer never occurs. But we can explain that. It's not random. The body is strategic. It's strategically choosing tumors in specific locations. Okay, so I'm very excited about this particular development in my theory, extending it to sort of the tissue-specific case. Let me know your thoughts in the comments. Thanks very much for listening.